Good morning and welcome to today's webcast, Emergency Preparedness, partnering with the right O&M company for your solar PV assets. My name is John Evans from Webcast Experts. We're the producer of today's event. We are a division of Krishnan and Associates, a provider of technical marketing, market analytics, and business development consulting services specifically tailored to the global energy and power generation industries. Our presenter today will be Mike Loser, Director of Operations for Strata Solar Services based in Chapel Hill, North Carolina. Mike leverages 8 years of large customer account ownership as a foundation for his specialty in asset management and operations, where he has been focused since 2014. At Strata Solar Services, he has expanded upon and streamlined the services that the company performs on solar investment projects. In this capacity, Mike manages a team of asset management, plant operations, and business operations professionals who are experienced in multiple disciplines, including legal, accounting, financial, engineering, and data science. Mike has a bachelor's degree in business administration from Emory University with dual majors in finance and consulting venture management. If you have questions as this presentation proceeds, simply write them onto the Q&A box on your screen. We will address as many questions as time permits at the conclusion of the presentation and provide email responses to any questions that we can't get to. We will now turn the presentation over to Mike Loser. When you're ready, Mike.
Thank you, John, and welcome to all of our audience members. Appreciate you taking the time today to join us for our discussion of emergency preparedness on PV plants. The intention of today's talk is to give you a little bit of background about our company, Strata Solar Services, but then get right into questions that you should ask and things that you should be thinking about when evaluating an O&M provider and their preparedness for handling the worst case scenarios that you might run into on your PV plant. So the agenda looks a little bit like a quick introduction of our company, then move right into some of the questions that you should be asking when you're thinking about who will care for your plants over the years. And then we'll actually step into a couple of case studies, and that's the fun part in my view, where we look at real things that have happened and why the questions that we went over would have mattered for you to be ready to deal with those real world scenarios. So to start out, Strata Solar Services is a O&M company that handles PV assets, and it's an affiliate of Strata Solar dedicated solely to operations and maintenance. And it dates back to the beginning of Strata Solar, which is an EPC company, and began developing a lot of PV plants starting in 2009, really ramping up in 2010, 2011, and needing an operations and maintenance capability to care for the plants that it retained ownership in. So at the time, there were technicians and back office folks that began to be dedicated to operations and maintenance. And that gradually became a larger and larger need until it became big enough to become its own entity. And then a few years ago, we actually identified that we had reached a scale where it made sense to reach out to outside asset owners that had PV plants that were not necessarily developed by Strata Solar. And that was when we really kicked off the third-party business of Strata Solar Services. And now, of our roughly 1,800 megawatt portfolio, more than half of it is actually third-party that is owned, that was developed by companies other than Strata Solar. So I'm going to just begin by giving a few bullets here on what Strata Solar Services does. And it starts out with the Remote Operations Center, which is really at the headquarters and responsible for monitoring and operation and control of all of the PV plants under our O&M care. And so We do have a 24/7 remote operations center. That's a move that we made a couple of years back because we used to have a cell phone that all calls got forwarded to during nighttime hours, and the operators would just work regular day shifts, and then we would here and there get calls from grid operators, and whoever had the cell phone that night would have already worked that day, and then they got a call in the middle of the night to deal with whatever came up during the night. The volume of nighttime issues got high enough that we ended up needing to turn it into a true 24/7, and you might think there's not much that goes on with a PV plant at nighttime, but you do have a lot going on in the power grid. You have to be available to speak with grid operators about conditions that might be affecting your plant, and you still can have events that happen at the plant during the night. So the other items that go on with the Operations Center are Newark SIP low impact compliance and real-time reporting and alerts, getting notifications out immediately to plant owners when something has come up with the plant. And the compliance we'll talk about a little more in just a minute here, but first I'd like to step into just a few other items that we focus on, and one of those is preventive maintenance scope. We really do put a lot of attention to developing a scope of work that applies specifically to a plant and is designed to maximize the life of the equipment and maximize uptime availability. We've got electrical remote power plant troubleshooting. It does start out remote, and then we have field technicians that are very specialized and have different areas of expertise depending on what plants they'll be working on. And we do a lot to try to remotely diagnose before we have to send a truck to a site. A lot of people have gotten very good at that in the last couple of years. So there are a lot of providers out there that have a good system to get as much intel remotely as they can before they actually have to send a truck and expend labor on a repair. And then, of course, growing out of the Southeast United States, one of the biggest things that we run into is vegetation and erosion. Two are not mutually exclusive. One can lead to the other, and we have had to develop a lot of expertise in this area because in the Southeast United States, it can very easily be a third of what you spend on O&M as a plant owner, and you can run into a lot of different situations when it comes to seed mixes and site conditions. So it's a very big focus for us. And through all of this, we've truly developed the remote intelligence approach that I mentioned earlier, where we do as much as we can from the operations center, and then there's actually a handoff to our performance analytics team so that operators can always be focused on what is happening in the real time. And that's really important because a few years ago, our operators loved to dive really deep into whatever was going on a PV plant. But now that we handle such high volume and we have plants that are connected to distribution and transmission grids, the operators always do have to be ready for that next phone call. So we really target about 30 seconds maximum for an operator working on an issue before it's handed off to a performance engineer and then ultimately dispatched to the field for power plant technician to visit and diagnose and make a repair if necessary. So one thing that we found, and we've seen a lot of other people doing as well, is that the SCADA system gives a lot of great intelligence, but then you do as an O&M provider need to have the capability to model performance separately from what the software system is already telling you, and to do a true expected plant energy output analysis, take that into how DC components are performing, and remotely identify any issues that could be taking place with trackers and sensors so that once you dispatch to the field, it can be a very targeted field action. And a couple of charts here where we just modeled cases we'd seen of PV plants where the provider had really only been responding to SCADA alarms. So something goes offline and you go restore it, but there had not been a lot of efforts to optimize And so this is just an illustration of what you could be leaving on the table if you're not paying that level of attention. There's one more area here that I do want to spend a couple minutes on, and it's Newark SIP Compliance. So this is a big deal when you get into larger power plants, and there are a lot of ways that a power plant can qualify to be impacted by Newark compliance, but it's good to do a study of the compliance requirements, even if you're not sure that you will be developing or owning or maintaining a PV plant that qualifies under NERC, just because it's really about best practice. And a lot of people, myself included, when they first hear about NERC, get very overwhelmed by all of the standards, and they kind of look like just big walls of text with a lot of technical jargon. So it is very overwhelming, and it's hard to get a brief digest of and get a good understanding of. So one way to look at it really is that it truly is just about being on the power grid and being a good neighbor on the power grid. And I almost wish somebody had told that to me before I started trying to teach myself the standards, because I think that I spent a lot of time just reading standards and not really understanding the intent until I got really deep into it. But NERC SIP compliance is intended to really just be a starting point as to how you should be behaving and how your plant should be interacting with the grid. And it's meant to be a baseline for best practice. You actually don't want to stop at just the bare minimum to meet NERC standards. And help me help you is kind of a good catchphrase there, because it's things that you can do as a generator owner or operator that make it easier for the power grid operators to manage the generator that you have under your control. And really a lot of it is truly about documentation and being very cautious and deliberate with everything that you do. We and our operators really focus on not multitasking, because these are very important operations that we're talking about. So that's one of the biggest takeaways for the operator, is just focus on one thing and document it very carefully. But you should check out the NERC standards for yourself. There are, like I said, several ways that a plant can qualify, and it's a good category to just understand, because we're dealing with solar farms, but they truly are power plants, and it's good to know how they will be expected to interact with the power grid. So then we kind of get into true root cause here. And again, this is all just important because of why we have to do what we do when a very large event is happening. It's good to not just be in the practice of flipping switches back on when something goes offline, because you really want to understand the root cause of what happened. And you have to be able to do that very quickly and at a very large scale during an emergency condition like the ones that we're discussing today. So the right combination of cutting edge technology, but just understanding of electricity is critical. I think there are a lot of people out there the last few years that have gotten really into the newer technologies like aerial surveys using drones, and that's great. We love that too, but it's important to also have engineers and people with true electrical knowledge, because when things go really wrong, you're dealing with a power grid, and you have to know how your plant interacted with the grid, why the occurrence happened, and how you can get back online and how you can do so safely. And so that's all well and good, but now I really want to get into questions that you should be asking, because a lot of what I just went over is Strata's approach to operations and maintenance, but like I mentioned earlier, there are actually a number of very qualified operations and maintenance companies out there. So certainly can't claim to be the only one. And really the point of today is for everyone here to learn what you should be looking at and assessing, and the questions that you should be asking to ensure that your PV plant is going to be cared for, even in the worst case scenarios that could come up. So listing a few questions on the slide here, but it's important to think about them and then come up with some more detailed questions to really vet the providers that you're considering for your expensive PV assets. First here is whether they're prepared to handle issues at a large scale. I think that there are a very large number of O&M providers across the United States and across the world that can do a really good job at handling an outage or an event, and they have the expertise to truly dig in and give great reporting on what happened, and even beyond events, just plant performance. There are a lot of people out there that can help optimize a PV plant. But the question then becomes, what if a lot of things happen at the same time? Because we do not have the luxury of spacing out what happens at our PV plants. And I'm sure that a lot of people here have run into that already, but what if there is a large grid event, a large weather event, and it leads to dozens of outages, dozens of damaged locations at the same time? That's when it really starts to become harder, and it starts to weed out some of the providers that are only one molecule deep in some areas. They only have one person who is a field engineer and can figure out exactly why something is happening. Then that person is going to be scrambling around to the dozens of different locations to diagnose and get everything restored. And the other thing that comes up then is, where would you be on the priority list? So if you're signing a new O&M contract with a provider, are you going to be the first customer that they're thinking of when that massive event happens, when dozens of the plants that they have under their care go offline? If you have 5 of the 100 plants that they have, are you going to be number 95 to 100? Do you have to wait a couple days for them to do the expert troubleshooting on other people's plants until they get to yours? And that's where it's good to really question what primary and backup resources they have available, and to really get into details on their staffing levels and equipment and even their own facilities, because it's great if they can dedicate the number of personnel that you think is appropriate on a good day, but are those personnel still going to be dedicated to your portfolio on a really bad day? Or are they going to be pulled in different directions and you don't have the coverage that you're used to, or just the ability to hire a higher volume of issue coverage? So another few questions here that are important to be thinking about and then developing your own question set when you're assessing an operations and maintenance provider are their relationships with grid operators. It's good to get some detail on an operations and maintenance provider's experience, because, for example, if they have a lot of experience with commercial rooftops, that is great, and it means that they can work very well with those types of systems. But it might also mean that they have a lot of experience on systems that are connected to a panel board in a commercial building, and they, in that type of work, don't have as much experience talking directly to a transmission desk, the grid operators. And it's a different style of communication. So you just want to make sure that they are experienced at talking. And, you know, one of the easiest ways to think about it with communications with a grid operator is 3-part communications, where an operator has to repeat back what they heard and the other person in the conversation has to confirm that they have it correct. Seems very simple, but it's just a good thing to make sure that your provider is ready to deal with if you have a plant that's sitting on a distribution or transmission grid, because the grid operators get extremely busy and they don't have time to fumble around. They need a call that's very straight and to the point and uses the lingo that they're used to. The next question is a really, really good one, because when you start to think about, let's say, a weather event that hits a very large territory or is very severe, it can cause extreme damage. So it's not what you're used to running into daily, where you might have one ground fault or a lightning strike that takes out 20 solar panels, you could actually end up with a need for true construction work. If you have racking tables that have collapsed or hundreds of modules that are removed from racks due to wind, other events, then all of a sudden it's not just two technicians taking the morning to fix something. You actually need to have dozens and dozens of construction personnel mobilized to rebuild portions of your PV plant. So that's a really important one, because the question there is whether the provider can get started right away or whether they're going to need an advance. Do they have the financial strength to place large material orders and mobilize large crews of construction personnel? And then around-the-clock coverage is another good one. I talked about it a little bit earlier. It's not a huge need for a PV plant to have people working all around the clock at nighttime, but here again, natural disasters or human-imposed disasters, grid conditions, do not wait conveniently for 9 a.m. to happen. So you can very easily have something strike in the middle of the night, and it's not really a comfortable thought to just have your PV plant sitting there for potentially 12 hours until somebody can get there and make sure there aren't unsafe conditions or there isn't something that is causing damage as time goes on, like a fire. So very important to just think through what could actually happen to your PV plant and what actions would your operations and maintenance provider take. So here's where we actually get into an in-depth case study that will show the importance of some of the questions that I asked you. And it is, like I said, it's fairly easy these days to find well-qualified operations and maintenance providers. I would consider us to certainly be one, but I think there are a lot more out there. So we certainly are not claiming to be the person you should call for all of your needs, but you should ask the right questions of anybody that you are calling for those needs. And as we step through this case study, you'll start to see why it's really important to ask before you sign that O&M contract and just make sure that whoever you're hiring will be ready to deal with larger scale issues. So the case study here is a hurricane that hit a portfolio that was under our care, and it was in North Carolina, and it occurred in 2016. So one thing that was very critical leading up to this storm and leading up to a lot of other storms that have not done the level of damage that we observed here is just the weather forecasting and the response to weather indicators. Our operations center has a screen where they will look at weather forecasts and assess any conditions that could end up causing a risk to portions of the portfolio that's under our care. And in this case, they were watching all the hurricane forecasts, and they saw that the path was headed reasonably close to the North Carolina shore. And so in the weeks and then days leading up to the hurricane, they began sending daily weather updates, just assessing the risk and the likelihood that it would actually reach portions of our portfolio. And based on those reports, our account managers were able to begin reporting out to our customers when it looked like there was some risk that their plants could be impacted by the storm. And of course, our operations center has a glass wall that can look into the operations center through, and so it became a gathering point for folks around the office because they would have the hurricane forecasting up, and everybody was just very interested in how things were unfolding and what the team was doing to begin responding. And then once it started to look like the hurricane truly was headed closer to areas that were in our coverage, we began refresher training on our emergency operation SOPs. And that ranges from what are the back office folks doing, what's happening in the operations center, how do we maintain staffing levels based on volume of issues that are occurring, all the way to how do we start assessing damage in the field safely, ensuring that the weather event is over and ensuring that everybody can safely reach the locations they're going to. Nobody's putting safety behind anything else on the priority list. And then we saw that the storm was getting more and more certain that it would be somewhere around the North Carolina coast, where at the time we had a lot of coverage. And so we began making specific plans for staffing adjustments and for having backup staffing ready. Those we also communicated to our customers. And then we even got to the point where we started to refresh the Operations Center backup planning in case there was a loss of access or a loss of power to the Operations Center. And risk area identification, that's, in the last few days leading up to the storm, the path got more and more specific. And so we started planning for specific plants that were in the potential path of the storm. Now, the other thing that happened here is as the days approached and it got closer to the expected landfall of this storm, it became clear that it was going to hit over a weekend. So you kind of rewind back to making sure that your provider is going to have around-the-clock coverage. There are a lot of folks out there who see the weekend as a less critical time for operations, and there are a lot that do have good coverage on the weekends. But just making sure that, number one, your provider has coverage on the weekends, and number two, if they have more of a skeleton coverage, they do have a way to ramp it up if there's an event that's happening. So again, you wouldn't be waiting for a couple days or even a holiday for answers as to what happened to your PV plant. Now, that is all of the preparation that went into the storm approach. And what happened then is, for us, Friday overnight was the final stretch of the storm approaching, and it started to become clear in this case that the storm was going to make landfall on the North Carolina coast, where we had a lot of assets under our care. So we kept watch over everything and had all different weather feeds coming through just to see if one caught some news before the other. And ultimately, Saturday morning, the storm did make landfall, and things started happening very quickly because we immediately had plants start to go offline, and we started to have to call in to grid operators to compare notes on things that were happening on the power grid. And the storm path actually got worse, too, as it made landfall, and it became clear that the storm was going to spend some time over our portfolio. So the areas that we had identified as risk areas during our preparation started to become the real deal. They were all in the storm path. And as the day went on, the storm did affect and cause outages and some damage at 57 PV plants that we were caring for in operations and maintenance. And so that's 57 plant outages and 57 locations with potential damage and flooding, wind damage, you name it. So the next thing that I'll show you is some of what we started to notice when we finally were able to get eyes on some of these plants after the storm passed. And then we'll talk a little bit about what we started to do as soon as the storm did pass. But this is, like I said earlier, this is the fun part. It's also kind of the terrifying part when you think about whether this could happen to your PV plant. First one here is not meant to be a photovoltaic. I know that's been a trending topic lately, but this is a true ground mount PV plant that got enough flooding from the storm that it reached, as you can see here, bottom of combiner boxes. It reached up to the very top edge of inverter pads. And so just terrifying to see this when you think about the value of all this stuff. And of course, the storm was worse than 100-year flood line. So you can design a plant thinking that you would never run into something like this, and then you do. And so this is obviously prevents you from accessing all parts of the site, and it presents a very serious safety hazard. So you definitely kind of highlight another part of your assessment of an O&M provider there, and in that they should be prepared for any type of safety decision and calculation. You know, what do you do in conditions that you might never experience, but when you do, you're not going to have time to go do research on how you best approach it. So pretty shocking level of water damage here. Wind was another big problem in the storm. So moving into that here, you can see that we came across several PV plants where there was serious mounting system damage, where racking tables had slipped and fallen, and that had resulted in something like you see here, where you have entire tables that have collapsed, or you have panels that have blown loose or broken due to flexing. And again, this is not a two-technician in an afternoon job, but it's important to assess the extent of it so that you know how much personnel and how much material you'll need to be mobilizing. Another type of damage that we saw was from trees. And you can see here that a tree came down and the mounting system was no match for it. The tree went straight through there, and you have severe damage to the racking and, of course, the surrounding modules. And, of course, trees coming down results of high winds. We also had cases where the winds were high enough that the wind alone blew modules off of the mounting systems, and in some cases, several hundred modules in individual PV plants blown loose. So this starts to give you a feel for the magnitude of what you can run into. And what I just showed you was 3 different plants, but of course, I mentioned there were 57 plants. Not all of them had anything as severe as this, but you can start to see that if you have a company who's just built out to do preventive maintenance on a rotating basis across their portfolio that they care for, they would be very stretched to be able to start getting those folks to every site to assess this damage right after a storm. So let's talk about that for a couple minutes here, because after the storm, and you can see another photo here of some severe flooding, that's yet a different plant. But the thing that we focused on throughout the entire storm and the after effects of it was safety, and we did right away reach out and make sure that all personnel were safe, make sure that everybody was okay personally with their property and their own well-being. And unfortunately, there was a Strata employee who lost their home, and so the company immediately began fundraising to get them a safe place to stay right away and to help them get back on their feet after that. And then we'll talk a little bit about what the operations center looked like this day. Every operator was constantly working from when the storm started to make landfall through the entire storm and the after effects of it. And we did have to bring the backup staffing that we had prepared on shift. It was folks who would not have been on their shift normally, but we brought the full force of the operations center and the field personnel, because as I mentioned earlier, the operations center, a lot of what they were dealing with was plant outages, and so because there weren't emergency conditions, we didn't want to tie up the real-time desk of grid operators for every single call that we were making, because some of them had to go through just a regular outage line. And so there was a lot of that, and then there was a lot of work ticket creation and aggregating data, whether it was reports that were coming in from the grid operator or from neighbors to the PV plants, and then dispatching out to the field teams. And that dispatch was a very coordinated effort because, as I mentioned there, we had to bring everybody to an on-shift status where they were able to start dispatching and looking at things. But even then, with 57 plants, that's a lot of ground to cover. And this was North Carolina, which is a lot of rural lands, and so these are not close together plants. So one of the big functions there that was happening in the operations center was the strategic dispatch and making sure that everybody was taking a route where we were going to cover all the ground in the quickest amount of time possible. And so, and we did. The storm cleared later that day, and through the weekend, we had every one of those 57 locations assessed first day, and then began more in-depth reporting the following couple days so that we could mobilize construction type repairs for some of the larger damages and get plants restored in the case of no damage or a smaller amount of damage. And so then we continued to coordinate with the grid operators because they too had experienced an incredible amount of damage to the system, and they were working around the clock as well. They, of course, had trees down on power lines. They had some areas where there was flooding in substations. So for them, it was also just an incredible effort that they were making, and it was great coordination between us and the grid operator and other operation and maintenance providers and their grid operators as well. And at one point, we did deliver sandwich trays to the grid operator because of the level of appreciation we had for them working around the clock tirelessly to maximize the uptime of the grid and to help us out with restoration of generation facilities. And there again, we did have plants, as you saw, with very large scale damages. So we had to begin construction takeoff visits pretty quickly because in some cases it was complete rebuild of some parts of the plant. So that's where those next couple of days we really got out there and started doing counts of rows that had types of damage and modules that had been blown off of racks. And then, of course, working with our customers to provide them with regular updates throughout the entire thing. On that first day, Saturday, we had emails out to everybody with basic reporting on what we had seen when we got to site. And then we continued to provide updates and then more in-depth reports because, of course, what they needed to do was to get in line with their insurance providers. So we supported insurance claims across the board and provided the level of detail necessary to start that process so that all of the damages could be properly assessed and wrapped into any insurance claims that were being made. So that takes us through one really big event that shows you what you should be prepared for. And it's something that, of course, would matter a lot to you for any plants that you owned in the territory of a storm like that. And you would want to make sure that your provider was going to be all over it and be giving you the level of information that you would want if you heard that there were catastrophic damages occurring in the area where you had plants. But there are a lot of other things that can happen to a PV plant. And so listed a few more here that are quite possible to encounter, and you can let your imagination run wild when it comes to other things. But the point really is the severity and the scale of what can happen to a PV plant or a PV portfolio. Fires are more common than I think some folks would think because of the high voltage and medium voltage that can have events, and then there also can be, as you see here, grass fires caused if there's an event where something blows and lands in drier grasses. So you have to make sure that your provider is prepared and works with local law enforcement and knows how to train local law enforcement and have them ready to respond and work together. Because as we all know, even if you de-energize a PV plant, and oftentimes you can do that remotely, you still have the panels that are getting hit by sunlight. So you still have a potential hazard out there. Another type of situation you can run into is an unauthorized person on a site, and this is something that we truly did run into with a fugitive from the law scaling the site fence to try to hide from law enforcement. But it can be anything. It can be people that are just trying to vandalize or steal from the plant, that break in. And of course, this is a major safety hazard as well, because then you have untrained person on site who may decide to go interact with some of the electrical equipment. So you have to have a provider who's ready to work with law enforcement and respond very quickly if something like this comes up, because they may be asked to take some action, or in our case, we decided to proactively de-energize the plant just to lower the number of components that were a risk to the person on site. And tracker issues are another thing that can be very large scale. In a storm like the one we talked about, or in any other wind event, you have to make sure that all plants that are under your provider's care are working properly when it comes to sun tracking, and that the trackers are going to properly go into wind stow mode, and that any rows that are not tracking have been identified quickly and can be manually put into a safe stow position. So tracker issues can crop up on a large scale, and that's where you do want to make sure that your provider is used to working with them and being proactive and knowing what's out there, so that when a couple hours before a forecast of high winds, that's not the first time that you're having to ask your provider whether all of the rows are ready to be in wind stow for the wind event. And then emergency grid conditions is another one that's really important. I talked earlier about just experience working with different types of grid operators, and that's such an important relationship because they have a lot to do to balance the generation load on the grid, and it's very helpful to have an O&M provider who is able to work in real time with that grid operator on your PV plant. And I mentioned the Newark SIP Compliance earlier, so of course that's the intent of that being there for large transmission connected assets, but this applies across the board. And if there are emergency grid conditions going on, the O&M provider might be asked to take the plant offline or change a plant set point. And there's not a lot of time to do that. It's something that's expected to be done in a matter of seconds or minutes. And so being prepared to think on your feet and know that everything is operational and not let an emergency grid condition be the time that your O&M provider realizes they've lost control of a breaker is very critical, because that can very quickly make grid conditions spiral out of control, or it can make the grid operator have to take their own measures to take the plant offline. And you just don't want to be in that position. You want an O&M provider that's ready to work through those things in real time. And that gets you back to the around-the-clock staffing and operators who are trained in working with all different operating entities. So those are just a few more things that you can run into with your PV plant, and why you should be thinking through the list of questions to vet your O&M provider with. But I've only covered a small fraction of what we could run into and what you need to be prepared for. So I do want to leave a little bit of time here for questions and answers, which I'd be happy to address now.
Yes, very good. Mike, that is the formal presentation. We did have a number of questions that were raised as the presentation unfolded, and we'll address them now as time permits. If we don't get to your question, rest assured we'll provide email responses shortly. First question has to do with the DAS platform. Mike, early in the presentation, you mentioned the importance of the ability to model outside the DAS platform. Can you elaborate on that in the sense that is this meaning that that needs to be done at the component level, or because the DAS models are inadequate? Some elaboration there, if you will.
Sure, it's a great question, and certainly not because DAS models are inadequate. I think there are a lot of very good data acquisition systems out there. And so some of them have very advanced modeling capabilities and the ability to drill down into individual components, and we love working with those systems. We do like the ability to standardize analysis of expected energy in DC health. And so even if you have a great data acquisition system, the point there is that you would want a provider who is able to get outside the box and get really into depth on performance analytics if you can't answer all the questions with what the data acquisition system gives you. Because a lot of times it'll give you really good indication of underperformance, and many of them will drill you down into the suspected components that's underperforming. But it helps to have a provider who's still able to then run through some of their own modeling to give you really specific field actions and sometimes even give you an estimate of the field repairs that would be needed to address it before you even have to pay to send somebody on site.
Okay, excellent. A question about insurance companies. When do the adjusters for insurance companies get involved in regards to when you interact with them?
That's another good one. So the adjusters usually will get involved once there's a full report of damage on site. And they typically want to be involved before significant repair work has started, which is why it's important to know that you'll be able to include your O&M provider in that coordination, because the policyholder is going to submit a detailed list of damages and any evidence, whether it's photos or an aerial survey. And then the insurance adjuster will have varying requirements. Sometimes they will want to get out on site themselves. Sometimes they have specific types of evidence that they'll accept, and then they'll need to work with the cost of all the components involved. So they usually do get involved once every component is accounted for that has damage, so that they can start working through what is the list of parts that would need to be ordered and an estimate of the labor hours. And then as an O&M provider, we would get our go-ahead once the adjuster has given the policyholder the green light that, hey, we'll cover this amount and here's any specific instruction we have for the repair work.
Does that ever become a bottleneck in the recovery process, or it's typically pretty transparent?
It can become a bottleneck in the recovery process. It's certainly something that needs a lot of hours on their side to go through the itemized list of damages and validate everything, and sometimes validate it against the original accounting data from the plant. So that's another party to really vet when it comes to large-scale events when you're selecting an insurance provider. How, if there are damages across a lot of folks' policies, will they be addressing your damages, and how quickly will they be able to respond to you and accept a list of damages and allow repair work to begin?
Okay. Some of the slides showed wind and rising water damage. Have you had to deal with damage due to hail?
We have had to do hail damage repair work, and it's something that can spread in density very quickly. If there is a dense hailstorm, and by that I mean a lot of hail in a given area of land, then you can end up with a very annoying problem of having some panels damaged throughout every single part of your array. So we've certainly seen cases where there's a dense enough hailstorm that every inverter ends up going offline due to something like a ground fault because some number of panels within its zone have been damaged. And so that's something that can, sometimes it can just be a minor annoyance, just a few panels need to be fixed after routine hailstorm, but it can get to the point where very quickly you have hundreds or even thousands of panels that need to be replaced, and sometimes repair work that needs to be done to even get the plant or an inverter back online.
Okay. Typically, would O&M companies provide a response guarantee in the event of an event? If the named storm or an event that's going to bring you on site, is there ever a response guarantee time?
There is. That's a really good question too, because there are often response times in contracts, and we certainly see those regularly. And you would still want to ask the questions that we talked about earlier, because sometimes it might be worth breaking the response time guarantee for the provider if it means that they have a guarantee in another contract that carries a larger penalty that they would rather not break. So it's still important to know the full-time employees that they have in different service areas and how they would be allocated if there were a massive event, because it might be easy to stay within the response times on a single outage, but it gets really scary when there are dozens of them.
Okay. Just regarding everyday, aka non-emergency situations, what are the expectations you should have from the O&M provider for regular maintenance, not emergency, but what are some of the scope items that should be expected from regular maintenance routine?
Sure. So on the preventive maintenance side, you certainly should expect that your provider's always able to do a very deep dive into how equipment is looking to really be prolonging its life. But when it comes to routine corrective work, outages that just come up on a day-to-day basis, you definitely want a provider who's able to get out there on the same day if you want them to, and it shouldn't matter whether it's a weekend or holiday. And certainly there will be cases where it wouldn't be worth the cost of them getting out there the same day. If you have one underperforming string and there's suspicion that one module has gone bad, you probably don't need them to be out there in 30 minutes, but you certainly don't want them to tell you it'll be 2 days for them to get out there if you have an inverter offline or a site offline. And of course, the cost benefit calculation of that truck roll comes down to what you get paid for a megawatt hour of energy on the plant, but you definitely want to make sure that they have the number of full-time employees that would make them capable of responding same day and, sometimes within an hour, depending on the type of plant that you're talking about.
Okay. Back on to another question about the DAS platforms. Do you have a preferred solution to managing multiple DAS platforms? Do you use them all individually, or do you have a tool that sets on top of them for your ops center working on a single platform?
Sure, that's been a hot topic in recent years because there are so many good options out there for data acquisition system providers. And for us, we will take on a plant that with anything, and we will wrap it into our fleet level analytics. So we'll pull the data out of the native DAS system and then get it into our own historian and alarming system so that we can take advantage of everything that the native DAS system has to offer and use the native DAS system for specific controls that are set up to be best done within the native system. But then we have the capability of looking at the data on a standardized basis, and that also gives an advantage to our performance analytics team, who's able to run the same modeling on all the plants without having to download data from all different portals and different formats. So it is a little bit of both. We do like to always make sure we have the access we need to the native system, but we do like to have the data in our central system so that we can always know that we're comparing apples to apples.
Okay. Sort of a site prep question. In the initial site prep for a location before you're involved, did you find it, if the site prep didn't adequately identify invasive vegetation species, can you deal with that after the fact?
We can. That's a big hit to the operating expense budget, or at least it can be, because if the site was prepped and seeded appropriately, then you can get it on a very regular schedule of vegetation abatement. But if there, like you mentioned, were invasive species that were not identified, then you can get to the point where there needs to be vegetation abatement constantly, and it needs to be very manual. And, we're talking weed eaters on dozens or hundreds of acres. So we can certainly offer all of the vegetation abatement services, but we also will sometimes recommend a reseeding if the cost benefit plays out right with that, where spending the money up front would save enough on a net present value basis for the years to come. Because it truly can, as I mentioned earlier, it can be a very significant portion of your O&M spend. So if you're suddenly having to double or triple the number of labor hours that it takes to keep vegetation below panel height, then that can be a huge hit, and that's where we would potentially work with a customer to identify opportunities for reseeding.
Okay. What happens if your central operations center becomes unreachable or loses power?
That's another really good question, and there are a couple of answers. One would be a backup plan, and that becomes important with very large plants that might be under NERC standard jurisdiction. And for those, operation centers often will have a backup generator. We have a backup generator that would run independently if the grid went down. But then the operation center might become unreachable, and so it's very good there to ask a question, and really I should add this to my list of questions when I present a topic like this, that what is the O&M provider's plan if the operation center loses power or there's no access to the operation center? In the event of the hurricane that I talked about, we had a plan in place where operators would have begun to head west as soon as conditions were safe, because the most damaged area we knew would be to the east, and they would reach a safe location to do what they would be allowed to do outside of the actual operation center, which would have been a lot of the coordination. We wouldn't have had them doing plant control from a separate location that was not within our policies and procedures. But that's a really good one, because you've got to know what they would do. It is possible, and if they have a backup generator, great. If they don't, that can still be perfectly fine, as long as they can walk you through what they would do if they lost power or if they have a generator and they weren't able to get there.
Okay. I had a question that came in about staffing. How does an O&M provider carry adequate staffing for large-scale emergencies without having too much bandwidth during normal operations?
Sure, that's a balance that is very delicate, and it becomes a lot easier when you reach a certain scale, because if you're only caring for, let's say, 2 power plants, then you have kind of a maximum number of technicians as an O&M provider that you could carry without just losing money on the 2 power plants. But once you have a lot of plants in a geographical area, then you can start to have some shared resources. So that's where the question of, how many full-time employees by function do you have in each area becomes very important, because maybe they have dedicated technicians to individual plants or individual regions, but then if they're big enough, they can have technicians that float. And so in a non-emergency situation, those technicians are basically just going wherever the most corrective work is happening to make sure that it's done quickly and that the provider's within their response times. And then when the emergency situation happens, they just have more bench strength with all those floating technicians able to be part of the teams that are rotating around and triaging every site.
Okay. Sort of a building on that, what happens if the employees are unable to reach the work sites due to road conditions?
Yep, that's incredibly possible in a situation like we described, as you saw the amounts of water and wind damage. And there were a couple of sites in the case study we went over that were not at first reachable due to water on every possible roadway that led to the site. And their safety has to always be the number one priority. There are times when you just have to make the call that you're not going to be able to reach a site until conditions clear. Might be that, like I said, water that gets in the way or trees that have come down, and it's really there about just transparent communication. So making sure that you do have a good system for providing updates, and that's where you want to make sure that your provider has back office support that will be making those communications, whether the news is good or bad. Either we got on site and we saw these conditions, or hey, we can't reach the site right now and we can't even see it because there's water covering all the roadways for miles. And then, basically we'll keep checking, and once conditions clear on one path to the site, then we'll get there and assess it. But we made it very clear throughout the entire event there that safety is always first. Don't do anything that you even have a question about whether it would be safe to do.
Okay. Before an expected storm, would it ever make sense to turn off inverters, or the whole plant for that matter, take it offline before an expected storm as a preventive measure?
That's a good one. A lot of times you can rely on the protective devices in place. We like to talk to the equipment vendors for any inverters, for example, that we'll be caring for, and get their input on it so that we know that what we've done is in line with the manufacturer recommendation. And typically the answer that we get is that something like an inverter will self-protect if something happens. So that it would not often make sense to de-energize in advance. However, the grid operator is another party that is very good to be coordinating with. So your O&M provider should be working with them on, hey, there's an upcoming storm. Do you want us to do anything to prevent instability on the grid? And oftentimes, this is what they deal with every day. So they oftentimes won't need help. But that's just another thing to think through, is whether it would help to come offline if you had a reasonable suspicion that you were going to have an issue at the plant.
Okay, very good. Last question. You mentioned in North Carolina in one of the slides there were some 57 plants that were under your purview. What are the geographic limits, the geographic space in which Strata Solar Services operates?
Oh, very good question, right? And there were 57 under our care at that time that went offline. There were many more that did not. But today we have a very strong coverage in the United States Southeast, and then we have newer portfolios where we've grown outside of the Southeast. And so we've got a presence in the United States Northeast, and we have several plants scattered throughout the Midwest and the Pacific Coast, the California, Washington area. So it's basically grown out of the Southeast. And when we get to the point where we have line of sight to enough of a portfolio in a new geographic area, then we will deploy a regional depot just like we would in a portion of the Southeast over the past several years. So today we have the very most coverage in the Southeast, but then over the last couple of years, we've become recognized as a national provider. So we are present at, really, I guess now that I kind of look at the map of where there is solar, it's everywhere that there is solar in the North America, United States specifically, we have some presence.
Okay, excellent. Well, we've reached a hard stop, and this is the exhaustion of our available time. Again, if we didn't get to your questions, we will provide email responses. Thank you, Mike, for this excellent presentation. We hope it has been productive for our audience, and thank all of you for spending some time with us today. This presentation has been produced and marketed by Webcast Experts, a division of Krishnan and Associates. Please keep an eye out for future events from us, bringing you more information on products and services within the power generation industry. Feel free to contact us at 203-921-1800 or email my colleague Luke Rathel, indicated here, luke@webcastexperts.com. For any questions you may have on organizing a webinar, if you're interested, any subjects of interest you may have for future webinars, or to access any of our previously held webinars that are now available on demand. This concludes our presentation. Thank you and have a good day.